Welcome back, dear students. So in the today's sessions we will discuss about hydrogen bonding. This is a special type of bonding exists in water molecule, biological systems, etc. So I think you have heard about this hydrogen bonding many times. Okay. So let's start with hydrogen bonding. Okay. Hydrogen bond. So this is an example of a molecule that shows hydrogen bonding. What is this molecule? Yes, this is water. Okay, H2O. Solid line represents the covalent bond, whereas this dotted line represents hydrogen bond. Okay, we know that oxygen is highly electronegative than hydrogen. Okay, as a result of the electronegativity of this oxygen, it will tend to attract the shared pair of electrons present is OH bond. Okay, and as a result of this attraction or force of attraction, what happens is the shared pair of electron is little bit towards this oxygen atom, concentrated towards this oxygen atom, and the electron density near oxygen atom is slightly higher than expected. So as a result, what happens is oxygen gets a partial negative charge. Okay, and similar things happen in another molecule of water. Okay, and this partial negative charged oxygen atom attracts hydrogen atom with a partial positive charge. Okay, hydrogen atom of another water molecule with a partial positive charge, and this attraction is the reason behind the development of hydrogen bond, or we can say that this type of attraction is known as hydrogen bond. Okay, so let's say another example here. This in the case of hydrogen fluoride also we can see the such type of hydrogen bonding interaction. Okay, here fluorine is the most electronegative element, so fluorine gets a partial negative charge and hydrogen gets a partial positive charge, and this positively charged hydrogen is get attracted by the negatively charged fluorine of another molecule, and thereby forces the development of hydrogen bond between these two atoms. Okay, so the the solid line represents the covalent bond, and the bond length is nearly 100 picometers. Okay, but in the case of hydrogen bonding between hydrogen and fluorine, the bond length is nearly 150 picometers. Okay, now let's see the definition of hydrogen bond. We can say that it is the attractive force which binds hydrogen atom of one molecule with electronegative atom of the same molecule or another molecule of the same substance or another substance is known as hydrogen bond. That means hydrogen bond may occur within the same molecule or with another molecule with another molecule of the same substance or different substance. Okay, so that is the definition of hydrogen bond. Okay, so what are the characteristics of hydrogen bond? These hydrogen bonds are weaker than covalent bond. Okay, covalent and the bond dissociation energy or the bond strength ranges from 10 to 40 kilojoules per mole. Okay, and as we expected, this bond length is larger than pure covalent bond. And what causes the formation of hydrogen bonding? It is caused by the electronegativity difference between hydrogen and the electronegative element. Okay, this is the most important thing. Okay, there should be electronegativity difference between hydrogen and the second element, that is the electronegative element. And due to this electronegativity difference, what happens? There develops a partial positive charge on hydrogen, and usually they are represented by dotted lines. Okay, and because of this hydrogen bonding, the molecules may have a tendency to tendency to attract each other and exist as a cluster of molecules. Okay, association of molecules occurs, or we can say that they exist as a cluster. Okay, so these are the important characteristics of hydrogen bonding. Now let's see what are the conditions for hydrogen bonding. The most important condition is that electronegativity of the hydrogen, electronegativity of the atom bonded to hydrogen. There should be a difference between the electronegativity. Okay, and second one is the small size of the electronegative atom. Okay, so these are the two main conditions responsible for hydrogen bonding. First one is high electronegativity difference between hydrogen and the bonded atom, and second one is the small size of the electronegative atom. The smaller the size of negative atom, greater will be the attraction for the bonded pair. See, in this example, this is ammonia, okay, and this red dotted line represents hydrogen bonding interaction between nitrogen and hydrogen, and this is the hydrogen bonding interaction observed between the ammonia and the water molecule. So see, this red dotted line represents the hydrogen bonding. Okay, nitrogen and with the hydrogen of water molecule. That means we can say that ammonia is soluble in water. Okay. Now, so you have to find out the answer for this one. Ammonia shows hydrogen bonding while HCl does not, although both nitrogen and chlorine have the same electronegativity difference. Same electronegativity of 3. Why? This is a possible question. Okay. Ammonia shows hydrogen bonding while HCl does not, even though both nitrogen and chlorine have the same electronegativity. Why? Because we can explain that this even though the electronegativity of nitrogen and chlorine are the same, the size of chlorine, the size of chlorine is larger than that of nitrogen. Smaller the size of electronegativity atom, negative atom, greater will be the attraction for the bonded electron pair. Therefore, ammonia shows hydrogen bonding, whereas HCl does not. Okay. Then let's see what are the different types of hydrogen bonding exist in certain molecules. There are two types of hydrogen bonding. First one is intermolecular hydrogen bonding, and second one is intramolecular hydrogen bonding. Hydrogen bonding resulting from electrostatic forces of attraction between the positive hydrogen of one molecule and an electronegative element of another molecule of the same substance or different substance is known as intermolecular hydrogen bonding. So, this is the definition. That is the bonding exists between two molecules. Okay, between two molecules. That is intermolecular hydrogen bonding. This intermolecular hydrogen bonding is responsible for association of molecules. Okay, and due to this intermolecular hydrogen bonding, there are boiling point elevates and volatility also elevates. Okay, all these things will happen. Okay, see, this is the example of intermolecular hydrogen bonding exists in water molecule, and this is another example of intermolecular hydrogen bonding exists in hydrogen fluoride. Okay, then the second type is intramolecular hydrogen bonding. Here, the hydrogen bonding resulting from the electrostatic attraction between hydrogen and an electronegative atom of the same molecule is called the intramolecular hydrogen bonding. That means here the hydrogen bonding exists within the same molecule. Okay, within the same molecule. That is the difference. Okay. See, this is an example of orthonitrophenol. Here, this hydrogen atom, partially positively charged hydrogen atom gets attracted by negatively charged oxygen atom of the nitro group present in the ortho position. Okay, so here you can see the intramolecular hydrogen bonding. That is, the bonding exists within the molecule. Okay, then let's see what are the consequences of hydrogen bonding. Due to this hydrogen bonding, that is due to intermolecular hydrogen bonding, high boiling point occurs. Okay. Second important thing is steam volatility. Example, paranitrophenol, whose boiling point is 279 degrees Celsius, is non-volatile, whereas orthonitrophenol with a boiling point of 216 degrees Celsius is steam volatile. Why? Because this is the example of orthonitrophenol. Here you can see that here exists intramolecular hydrogen bonding, whereas in the case of paranitrophenol there exists intermolecular hydrogen bonding. As a result of this intermolecular hydrogen bonding, they exist as clusters. Okay, so we have to apply more energy or more heat energy to expel that this or paranitrophenol into its gaseous state. Okay, so we can explain on the basis of its intermolecular hydrogen bonding. Now the third one is solubility. Here the solubility of lower alcohol in water. Okay, what is meant by solubility? So see, this is the example. This is an example of ethanol, which is dissolved in water. What happens is, due to hydrogen bonding, it dissolves in water. Okay, you have to, if there is any question related to the solubility, you have to write down you have to draw these structures also. Okay. Then the fourth one is physical state. Okay, physical state. We know that water is a liquid, whereas hydrogen sulfide is a gas. Okay, why? Because sulfur is less electronegative than oxygen, and the size of sulfur also high. Okay, so both these conditions are essential for hydrogen bonding. Higher electronegativity and a smaller size of electronegative atom. Both these two conditions have to satisfy. Okay, but in the case of sulfur is less electronegative than oxygen, and also size of sulfur is also higher than that of hydrogen. Therefore, there is no chances of hydrogen bonding in the case of hydrogen sulfide. Okay, then the fifth point is that ice has lower density than water. Why? We know that in water, in ice, the hydrogen bonding between water molecule is more extensive than that in liquid water. Okay, more extensive hydrogen bonding can be observed in ice molecules. The hydrogen bonds are weaker and therefore longer than covalent bonds. Therefore, in ice, the tetrahedral arrangement of water gives rise to an open cage structure which contains a lot of open spaces. Okay, so many voids are there within the ice molecule. As ice melts, some of the hydrogen bonds are broken and the molecules come closer to one another than they were in the solid state. As a result, the volume decreases and the density increases. Thus, density of liquid water is higher than that of ice, and ice floats over water. That means in ice there are a lot of void spaces in which air bubbles are embedded. Okay, so this is the reason. So by this let me conclude the session. So if there is any doubts, you can ask me freely. Okay, now thank you for listening. Have a nice day.